Hey guys, today we are going to be going into random variables. So this is when you have a sort of setup where you have a lot of different outcomes, but each one has a different sort of weighted probability. If we come over here, this is how they're sort of put together. In terms of insurance payouts, which is what we have here, we have a $10,000 insurance payout, so this is one possibility. We have a $20 payout, which is another possibility, and then a $0 payout, which is our third possibility. This covers all of the possible payouts you could get from this insurance policy. But each of these payouts have a different probability of occurring. So our $10,000 payout has a 1 in 100 chance in occurring. Our $20 payout has a 5 out of 10, so 5% chance of occurring. And then our $0 payout has a 94% chance of occurring. So this models real life scenarios really well, and then we can do a lot of things with these models, which is what we have next. So there's this thing called the expected value. So what it means is essentially if we have tons of people who buy the insurance policy, we observe them for some time. So if we take the amount of money that each person got and then we average it all together, that is our expected value. So the way we calculate expected value is we take our first payout times its corresponding probability, plus our second payout times its corresponding probability, and then you do the same thing for all of the possible outcomes. So if we were to calculate that for this model, it would be our first payout, so $10,000, times its probability, so 1 over 100, and then plus our next term. So we do the same thing for the $20 payout, so our payout times its probability, 5 over 100, and then the same thing for our last one, so 0 times 94 over 100. So this is our expected value, or also known as the mean payout. So this would be equal to 101. So our expected payout, or mean payout per person, is $101. Note that this 101, so our outcome does not have to be one of the possibilities that were listed up here, because this is a mean value. So now that we have a mean value or expected value, we also have a standard deviation. So I've mentioned this briefly before. Your standard deviation is derived from a term called your variance. So your variance is always denoted as sigma squared in these cases, where sigma is your population standard deviation. What we first do when we calculate our standard deviation is find the variance first, and then take the square root of it to get our sigma, so our population standard deviation. So we would take the square root of this big term here. The way we calculate it is our mean value, so that is our expected value, that's what we got up here, minus our first payout, and then you square that difference and multiply it with the corresponding probability of that payout, and then you add that up for every single term. So what that would look like is here. So let's calculate our variance first. Is equal to our E of x minus our first payout. So our E of x, as we know, is 101. So 101 minus our first payout, so $10,000, squared times the probability of the $10,000 occurring, so 1 over 100. And that is our first term. For our next term, we do the same thing, but now with the values corresponding to this column. So we add again our mean value, 101, minus the payout, so 20, squared times the probability of 20 occurring, 5 over 100, and then our last one, so 101 minus, this time it's 0, and then times the probability of that occurring, which would be 94 over 100 squared. And all of that is equal to a big number. It is equal to 989,819. So that is our standard deviation squared, our sigma squared, which can also be called our variance of the data. So now that we have found the variance, we just need to take the square root of it to get our standard deviation. So our sigma is equal to the square root of 989,819, and that is equal to about 994.896. So this is our standard deviation for this particular scenario. Now that we know how to calculate the mean, so our expected value, and then our variance and standard deviation for a random variable. Now, what about if we make some transformations to this model? So let's say we go to every insurance policy and we add $5 to it. So every insurance policy, no matter the outcome, gets a $5 boost. Now there is a 1 in 100 chance of getting a $10,005 payout. There is a 5 out of 100 chance of getting a $25 payout, and a 94% chance of getting a $5 payout. And we want to derive that based off of the expected value we had to begin with. So let's say last year we went with the old model, and this year we're going to add $5 to everything. So the way you would calculate that is your new expected value, whenever you add or subtract some number from it. So in this case, we're adding $5 to all of our insurance policies. That is just equal to our old expected value plus or minus whatever value we're doing. So in this case, we're adding 5. So that would be e of x plus 5, which is equal to e of x in total plus 5. And our old e of x was 101, if you'll remember. So adding 5 to that, our new expected value, our new mean payout, is $106. So now let's say, what if instead of adding $5 to everything, we multiply all the payouts by 5? So in this case, we're now multiplying our old variable times 5. So that is what our x represents here. Our x just represents some random variable that we're doing. This is equal to our old e of x, so our old expected value times 5. So our old expected value was what? 101. So multiplying that by 5, we get a mean payout of $505 if we were to multiply every individual payout by 5. So now that we know how to transform the mean, we also need to know how to transform the standard deviations. So note, I used VAR here. That stands for variance. I'm not using the direct standard deviation because variance is a lot easier to work with. Now that we know how to transform the mean, we also need to know how to transform the standard deviation. So note here, I'm using a notation that says VAR. So VAR here means variance. So you would read this as the variance of x plus c, where x is our random variable. The first one here is our old scenario where we added $5 to each possible payout. So it's our 1 in 100 chance of getting a $1,005 payout. So writing this out, it would become the variance of our random variable plus 5 to each value. It's just equal to our old variance. Let's say you're standing at the origin of a coordinate plane, and then you hold your hands out in front of you. There is some distance between your hands, right? So let's say the distance between your hands represents the spread of your data values. So now, holding your arms still, take 2 steps to the left. So your arms have moved with your body, so the x-coordinates of your 2 hands have changed. So your entire data values have shifted upwards. However, the actual distance between your hands didn't change. So the spread of the data still remains the same. Therefore, whenever you add some data points or translate data in any direction, your spread will always stay the same. So our variance is still equal to 989,819. And then to get the standard deviation from there, you would square root that and get $994.94.6. So that is our translations. Now we have, if we were to multiply everything by 5 again. So the variance of 5 times our random variable is equal to whatever number we multiplied on, so 5 squared times the variance. So again, our old variance is 989,819. So it would look like this. Whatever number you're multiplying to the data set, it gets squared and then multiplied with the variance. If you want to think about it in terms of standard deviation instead, then our notation would look a little bit different. So the standard deviation is equal to the absolute value of A times the old standard deviation. These two will still give you back the same value. If you were to calculate this out and then take the square root of it, you would get 4,974.482. And then if you were to take the absolute value of 5 times our standard deviation, so 994.946, you would get the same thing. So 4,974.482 if you don't round this one off. This is actually a much longer decimal, so if you just put this into the calculator, you'll get 4,974.73, but that's just because of a rounding error. If you took the entire decimal and multiplied it with the 5, you would get this number. So that is for single distribution transformations. Now we have two distributions. So let's say you get two insurance policies. So you want to know the expected payout by combining these two policies. Let's say the mean of our first payout, so E of X is equal to, let's go with the old distribution, so $101 with a standard deviation of $994.94.6. So we have distribution X over here. Normally you wouldn't notate it directly as sigma, you would notate it as variance of variable X is equal to 989816. Now we have insurance policy Y. Let's say the expected payout for this one, so E of Y now, is equal to $150, and then the variance of this distribution Y is equal to 50. So that would make our sigma the square root of 50, which would be 5 root 2. So now that we have both of these insurance policies here, what is the combined expected value? The expected value when we add variables X and Y is equal to the expected value of X plus the expected value of Y. So 101 plus 150, which would be equal to 251. If we have both of these insurance policies on hand, we will expect a payout of $251. I also did not mention this, but the actual formula should include a plus minus. If we were subtracting these two distributions instead, like X minus Y, then we would just do 101 minus 150. Whichever direction the question asks, that's the direction you're going to add or subtract in. When you combine the X and Y distributions, no matter whether you're adding or subtracting, so even if you're subtracting the X and Y distributions, the variance of this new distribution that you're getting from adding X and Y is always going to be equal to the variance of X plus the variance of Y. You would never subtract variances, ever. So our variance of distribution X was 989,816, and then plus our variance of Y, which was 50. So adding that together, we get 989,866. So the standard deviation, which is the square root of the variance, is equal to the square root of this, which is equal to 994.920. You can think of your variance as your sort of error. So it's a measure of your uncertainty regarding your mean. So let's say you have a cereal box. In your cereal box, you have a rough estimate of how much cereal is in there. You can't be completely exact in how much cereal is in your box, right? So you already have some uncertainty sitting there. Now let's say you pour some of the cereal out. So you have subtracted from your distribution of your cereal box. So now that you have taken out some cereal, you can't be completely exact when you just randomly poured out some cereal. So your uncertainty has only increased because you were already uncertain as to how much cereal was in your original box. Now that you have poured out another uncertain amount, you're even more unsure as to how much cereal remains inside of your box. So even though we have subtracted from our cereal box, our uncertainty, so our variance has only increased, which is why we always add variances. Variance only increases, it does not decrease. That's all for today, so thanks for watching. Hope you learned something. Peace.